Here we want to solve a quadratic. Now from the title you can tell you have to complete the square, but say it's not specifically titled like this. How can you tell when completing the square could be a good option? Mainly that you can't factor this. You notice there's nothing that multiplies to 10 that would add to 8, like 5 and 2, 10 and 1, so you can't think of anything that works. You can always use quadratic formula, but if you see that you have nice, even, kind of whole numbers, especially if it just starts with an x squared, a 1x squared, then a lot of times completing the square can be faster than quadratic formula. So first thing you want to do is subtract 10 from both sides. If 10's not the number we want there, we're going to fill in what number would work better there. So then if we're brainstorming, I like to think one step ahead and say, well, what would this look like when it's factored? Well, think about when you FOIL something. This 8 is going to come from this number, whatever number I put here, plus itself, because I'm trying to factor it to a perfect square. So my inside-outside term will be 4x and 4x, which add to 8x. And so notice how that automatically, if you're FOILing, forces your last term to be 4 times 4. So if this is 4 plus 4, this is 4 times 4. Now I can't just randomly add something to one side of the equation unless I add it to both sides of the equation. And so now why is that useful? Because this whole thing factors to this. And on the other side, I have negative 10 plus 16, so 6. So now I'm ready to be able to take the square root of both sides to get rid of the squared, which is the power of this, right? Once I have a squared all by itself, I can use square root property. And so this says x plus 4 equals positive or negative square root of 6. And then finally, to get x by itself, we can subtract 4 from both sides. And remember that technically means you have these two answers. Plus or minus is just a shorthand for saying that it could be plus square root of 6 or minus square root of 6.